Welcome to GCSE Maths Help. Today we're going to be looking at sequences exam paper questions. This video is a follow-on from my sequences key points video, which I will link in the bio below. If you haven't watched that video, you might find it useful before looking at exam questions. For everyone else, let's get started. So for our first question, we're going to look at a linear sequence. The nth term of a sequence is 2n plus 1. The nth term of a different sequence is 3n minus 1. Work out the three numbers that are in both sequences and between 20 and 40. So for this question, I'm simply going to list all of the numbers that are in both of the sequences between 20 and 40, and then we can circle which ones appear in both. So for 2n plus 1, I'm going to start with the 9th term, because when n equals 9, 2 9s are 18, plus 1 is 19. When n is 10, the next term is 21. When n is 11, the next term is 23. When n is 12, the next term is 25. And we can pop the next ones in, 29, 31, 33, 35, 37, 39, and then 41 is where I'm going to stop because it's outside the parameters. So for the other sequence, 3n minus 1, I'm going to start with the 7th term because 3 times 7 is 21, minus 1 is 20. So 20 is actually in this sequence. So when n is 8, we've got 23. When n is 9, we've got 26. When n is 10, we've got 29, so we're adding 3 each time here. So we've got 32, 35, 38, and then 41 is where I'm going to stop because it's outside the parameters then. So then we can just circle the three numbers that appear in both lists. So we've got 23, we've got 29, and we've got 35. So there are our answers, 23, 29, and 35. So for our next question, we're going to have a look at a quadratic sequence. We learnt in the key points video the procedure you have to go through to find an expression for the nth term. If you haven't watched that video, I suggest you go and have a look at it now because this gets a little bit complicated if you don't know the step-by-step process. So here are the first four terms of a quadratic sequence. We've got 11, 26, 45 and 68. Work out an expression for the nth term. So it's going to be in the form an squared plus bn plus c. So step 1, we write out our term numbers, including 0. So n, we've got 0, 1, 2, 3 and 4. So the next row is going to be labelled C, and these are the terms. So we don't know that term yet. And then we've got 11 is the first term, 26 is the second term, 45 is the next one, 68 is the next one. Our next row is labelled A plus B, and these are the differences between the terms. So the first one we don't know the difference of yet because we've got a question mark. The difference between 26 and 11 is 15. The difference between 45 and 26 is 19. The difference between 68 and 45 is 23. So the last row is going to be labelled 2a, and that is the differences of the differences. So we don't know the difference between our question mark and 15, so that can be another question mark. Difference between 19 and 15 is 4. The difference between 23 and 19 is 4. So at this point, this whole row should all be the same values. So now we can go about filling in our question marks. So if our 2a row, everything is equal to 4, we can cross that out and pop 4 in. So we can work out the question mark above it then. If the difference between the question mark and 15 is 4, then this question mark must be 11. The question mark above that, if the difference between that one and 11 is 11, this question mark must be 0. So we need these first values in the row to work out our nth expression for the sequence. So if 2a is equal to 4, we can say that a is equal to 2. So if a plus b is equal to 11 and a equals 2, b must equal 9, and our c value is the first one in the row, so that's 0. So we can say that a n squared plus bn plus c, and we've got values for this now, so our nth term is 2n squared plus 9n plus 0, so we don't need to write that in. So this next question is a fun little one that uses the key points we know from our powers and indices work. So part A says the nth term of a sequence is 2 to the power n plus 2 to the power n minus 1. Work out the 10th term of the sequence. So that is when n equals 10. So if we do 2 to the power 10 plus 2 to the power n minus 1, so that's 9. So we've got 1024 plus 512 is equal to 1536. So part B says the nth term of a different sequence is 4, and then in brackets 2 to the power n plus 2 to the power n minus 1. And we need to circle the expression that is equivalent to this. So at first glance they're trying to trick you here with the 8's in the options for answers, because 4 times 2 is 8. But if we're looking at these equations in terms of 2, we know that 4 is equal to 2 squared. So if we replace that in our equation, we've got 2 squared, 2 to the power n, plus 2 to the power n minus 1, then some of our indices rules come into play. So if we expand out these brackets, we've got 2 squared times 2 to the power n. So we know that when the bases are the same and we times them together, we need to add the powers. So that gives us 2 to the power n plus 2. And then the other half of the bracket, we've got 2 squared times 2 to the power n minus 1. So we need to do the same, we need to add the powers here. So we've got 2 to the power n minus 1 plus 2, so that's 2 to the power n plus 1. So this first expression is the one that we're looking for here. This next question says write an expression for the nth term of the sequence 2, 7, 12, 17. So the first thing to note is that it's the same difference between each of these numbers, so it must be a linear sequence. So we're going to draw out our table. Our first column is going to be the term numbers. So we've got 1, 2, 3, 4. Our next column is going to be the difference between them. The next column is going to be plus or minus, and the last column is going to be the terms. So the first term is 2, second term is 7, third term is 12, fourth term is 17. So let's calculate the difference between our terms. Each time we are adding 5 here to get to the next term. So in our difference column, we're going to times the term numbers by plus 5. So 1 5 is 5, 2 5s are 10, 3 5s are 15, 4 5s are 20. So now we need to plus or minus a number to get from 5 to 2. So we're going to minus 3. To get from 10 to 7, we take away 3. To get from 15 to 12, we take away 3. To get from 20 to 17, we take away 3. So this column, all the numbers should be the same. So for our nth term, we're going to write what we've done to the n numbers. So we've taken our term number, we've timesed it by 5, and then we've minus 3. So this is the expression for the nth term of the sequence. So our last question says, work out an expression for the nth term of the quadratic sequence. 2, 17, 40, 71. Give your answer in the form an squared plus bn plus c. So step 1 is to write the line labelled n. So these are our numbered terms, including 0. So we've got 0, 1, 2, 3 and 4. Step 2 is to label the line C, and these are our terms, so we don't know that one. Then we've got 2, 17, 40, 71. Step 3 is our line A plus B, and these are the differences between our terms. So we don't know the difference between our question mark and 2. The difference between 17 and 2 is 15. The difference between 40 and 17 is 23. The difference between 71 and 40 is 31. So our last row is labelled 2A, and this is the differences between the differences. So we don't know the first one. The difference between 23 and 15 is 8, and the difference between 31 and 23 is 8. So this is the row that all the numbers should be the same. So now we can work backwards and start filling in our question marks. So if our 2A row is 8, this question mark must be 8. The one above, the difference between the question mark and 15 is 8, so the question mark must be 7. And then the one above that, the difference between our question mark and 2 is 7, so the question mark must be -5. And these are the values that we want. So we can say 2A is equal to 8, so A must equal 4. A plus B is equal to 7. But if A is 4, then B must be equal to 3, and our C value is the -5, the first number in that row. So the expression for the nth term is an squared plus bn plus c, and we can pop in our values now. So we've got 4n squared plus 3n minus 5 is the expression for the nth term of this sequence. I really hope you found this video helpful. If you would like to have a little recap on the key points on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.